In this video, we will look at what makes a compound aromatic. Benzene is the most common aromatic compound. Note that many compounds contain the benzene ring. Here are more compounds that contain the benzene ring. Another compound that contains the benzene ring. These two antioxidant compounds are also aromatic. These aromatic compounds are used in organic light-emitting diodes. These aromatic compounds are colored. Scientists can change the color by changing or modifying the aromatic compound. Here are more colored aromatic compounds. And even more colored aromatic compounds. And even more colored aromatic compounds. This conjugated and aromatic compound is used in electronic circuits. Circuits such as switches and rectifiers. Polar organic compounds increase the efficiency of electronic devices. And here's an aromatic compound which is used in a molecular wire. Here are some common names for arenes or aromatic compounds. So here's the phenyl group, the benzyl group, and for substitute benzenes there's toluene, aniline, and anisole. Disubstituted benzenes are given the names ortho, meta, and para. So here we have orthoxylene, metaxylene, and paraxylene. Note the position of the two groups. Let's practice naming compounds. Use a common name to start. For example, this part of this compound is toluene, so this compound is called orthonitrotoluene. So stop the video and name the remaining 5 compounds. The second compound, note that this part is benzoic acid. So this is meta-bromobenzoic acid. And the third compound is either phenol, which is this part, or it could be toluene, which is that part. So it'll either be called para-methylphenol or para-hydroxytoluene. And these 3 compounds are for you future doctors. In organic chemistry, an aromatic compound is extra stable. So here are the 4 criteria which determines whether a compound is aromatic. So the compound has to be conjugated. It's got to be in a ring. The atoms in the ring all have to be in the same plane, and there has to be either 2, 6, 10, etc. delocalized pi electrons. So this is where this 4n+2 formula comes in. The first aromatic compounds that were discovered did smell. For example, benzene smells like a gasoline station, and toluene smells like paint thinner. Benzene is the most common aromatic compound, so stop the video and relate each criteria to the structure of benzene and answer this question. So note that we see carbon-carbon single bonds and carbon-carbon double bonds. All carbons are in a ring. The benzene ring is planar because at each carbon the shape is trigonal planar, which gives it an sp2 hybridized orbitals. And note that there's 2, 4, 6 pi electrons, and that fits the 4n+2 rule. And experiments show that each carbon-carbon bond in the benzene ring is the same length, and the reason is because of delocalization. So these 2 compounds smell like bacon, so apply the 4 aromaticity rules to show that these 2 compounds are aromatic. And stop the video. So each compound is conjugated. Note that these compounds contain carbon-nitrogen bonds instead of carbon-carbon bonds. The conjugation is in a ring. Note that the 6 atoms in each ring are all in a plane. And note that each compound also fits the 4n+2 rule. There are 6 electrons in each ring. So let's practice. Apply the aromaticity rules to identify the aromatic compound. Stop the video. So cyclopentadiene is not aromatic. It's a ring, but it's not conjugated. And note that the 5 atoms in the ring are not in the same plane, and it only has 4 pi electrons instead of either 2, 6, or 10, and so on. The cyclopentadiene anion is aromatic. The lone pair in the ring is part of the conjugated system. This carbon is sp2 hybridized, which makes all the carbons in the ring in the same plane. And note that there's going to be 2, 4, 6 electrons, which fits the 4n plus 2 rule. Pyridine, pyrrole, and furan are all aromatic. In pyridine, note that the lone pair is not part of the conjugate system, so there are 2, 4, 6 pi electrons in that ring. In pyrrole, the lone pair is part of the conjugate system, so there will be 2, 4, 6 pi electrons in the ring. In furan, only 1 lone pair is part of the conjugate system, so that gives it 2, 4, 6 pi electrons. DNA bases are aromatic. Let's practice counting those pi electrons, which makes the compound aromatic. So stop the video and determine how many pi electrons each base has. In purine, there are 10 pi electrons, 2, 4, 6, 8, and then the lone pair are the 9th and 10th. In adenine, there are also 10 pi electrons, 2, 4, 6, 8, and again, lone pair and nitrogen's part of that conjugate system. Guanine has 10 pi electrons. Note that there's 2, 4 from the lone pair, 6, 8, and then 10. In pyrimidine, there's 2, 4, 6 pi electrons. In thymine, there's 2, 4, 6. And in cytosine, there's 2, 4, 6 pi electrons. So let's identify which biomolecule is aromatic. So stop the video and apply the aromaticity rules to each compound. So vitamin B6 is aromatic. Glucose is not aromatic. And in NAD+, this ring is aromatic, and that ring is aromatic. So some aromatic compounds may be found in space, perhaps because they're so stable. The largest aromatic compound known has 50 pi electrons, so stop the video and count those pi electrons. And the smallest possible aromatic ring will have 2 pi electrons.